Hello, this is Manda. My project is about code summarization with large language models. So as we know, reading code is an important task in software engineering, and it can become very timely when the code becomes more complex. And that's why programmers need to add comments for code for the readers to understand the code. So this project aimed to test large language models, GPT 3.5 Turbo and GPT-4 on their abilities to summarize code automatically and see if they can be implemented in code summarizations. So for introduction, the automated code summarizations serves dual purpose in software development. So for the authors, it helps them generate the code maybe automatically. And for the reviewers, they can have immediate context and understand quickly about what the code's about. So the main problem I would like to talk about is, can decoder-only LLMs perform well in code summarization? So despite there are a lot of works in code summarizations, most of them are encoder-decoder models that designed for these tasks. So there are existing works in 2020, the paper transformer-based approach for source code summarization. It presented a basic encoder-decoder model with copy attention for code summarization. And then in 2022, another hybrid framework that combines the extractive and abstractive summarization came out. And this approach is an advanced application of transformers, and they have better performance than the existing encoder and encoder-decoder models at that time. And there's also graphic-based approaches that use a GSCS approach. They use the graphic attention network to process the tokenized ATS. And there's another hybrid framework that combine the RNN and attention that use the context of the code document and also the AST to give a broader view of the code summarization based on the context. So the two research questions I come up is first, how accurate can large language models generate summarizations compared to the human written summarizations after in-context learning. And I also want to explore how do GPT models scale with the size and the complexity of the code base. So I did this by splitting the code snippets by their length. So I have one subset with length with line numbers less than 3, and another one with line numbers larger than 10, and I want to evaluate the accuracy for the both subsets. And the second research question is, to what extent are the large language models generated code summary understandable and coherent for software developers? This will be evaluated by human evaluation and maybe in the future by another large language model, that if we find that large language model opinion is corresponding to the human insights. So the data set I used is the Python data set. It's the parallel corpus of Python functions and documentation string. So this data set have the body of code snippet and the description, which is a code summarization that display as part of the code comment. And the training set contain over 10,000 code snippets, and the validation and test sets both have 2,000 corpus. To cut off the training time and cost, I generated 2,000 prompts from the training and 200 prompts for testing. And I also select 40 code snippets for human evaluation. And here is a glimpse of the data. So on the left is the code snippet, and on the right is how the reference comments displays. And this is the prompt used for training. So basically, I use this for in-context learning for GPT 3.5 and GPT-4. So I generated this training from the training data, and for the testing prompts, they are very similar. The only difference is the response is removed because we want to save the generated response from the large language models and compare with the ground truth instead of giving them as a feedback. And here is the evaluation result. So it's kind of surprising. I evaluated them by the blue matter and the ROC-L for the accuracy, which is the similarity to human written codes. And before I trained the GPT 3.5 and GPT-4 model with in-context learning, I trained another GPT-2 with general training. And the result turned out that GPT 3.5 and the GPT-4 is very low in the blue score and relatively okay in the matter score, but still relatively low compared to existing encoder-decoder models. And they tend to generate long and detailed code summarizations that comprehensively summarize the code snippet, while the ground truth may just have a brief one-line summarization. So we can take a look at an example. So this is the code snippet, and on the left is the reference summary, which is only one line, and on the right is the GPT 3.5 summary. So with this comparison, so since the GPT-0.5 generates more comprehensive and understandable code comments for reviewers who first time see this code snippet. So I also evaluated the GPT 3.5 code comments with human evaluations. I put it with the ground truth human written comments together in a form, and the participants, I have 10 participants from the CS graduates in Vanderbilt, and I want them to select one of the two that they think is better for understanding. And the results turned out that over 80% of the preferred code snippets are generated by 3.5. So this may indicate that the large language model may not be very good fitting in accuracy of human written code summarizations, but they can generate understandable code comments. So there are limitations in this project. First of all, it's the quality of human written summarizations that make us concerned that if the human written summaries are good ground truth, and if the accuracy fitting to them is good enough. Also, the evaluation of blue matter and the ROC-L are only contain average scores. Maybe taking a look at the median score and the standard deviation may give us different insights. And for the next step, first of all, I would like to do assessment on the other programming languages, because the current project is only on Python, and we'll see if a large language model can do better with different programming languages like Java, Go, PHP. And also, there are multilingual cases which treated as edge cases and dropped in the training data set. But I think in the future, the large language model should be able to handle multilingual cases. They may be able to say receive a code snippet and generate code comments in different languages. And here are the resources and some references. And yeah, that's all. Thank you.